Hello everyone, welcome to MECH 3313 Thermo-Fluids Lab. I am MD Khan, a PhD student and instructor for this lab. In this experiment, we will analyze the performance of a wind turbine with varying load. The objective is to determine the effect of resistance change on voltage, current, or power generation for different phases. A wind turbine generates power using electromagnetic induction principle. We know a magnet has two poles, north and south, and it creates a magnetic field around it. So when a conductor is placed in that magnetic field and the magnetic field constantly changes, then the conductor sees an electric current in it. This phenomenon can be understood better using the analogy that the conductor is filled with free electron with negative charge, and the magnet, it has south pole with positive charge that attracts the electron, and north pole with negative charge that pushes the electrons away. So when the magnetic force or magnetic field changes constantly from positive to negative, the electron in the conductor, they sees a constant movement in them. This back and forth movement of the electron creates alternating current, or AC. AC has a sinusoidal shape and it changes its direction and amplitude alternatively. So the rotor magnet has two poles, north and south. When the rotor rotates, the opposite magnet poles pass by the coil in each half cycle. And that cycle creates an EMF, or electromagnetic force, with a reversing polarity. And this reversing voltage polarity, which is a positive in half the cycle and negative in the other half, it creates a reversing current as well. That's what we call AC current. An electrical AC generator has two basic parts, a stator and a rotor. The stator has the conductor coil and the rotor has the magnet. The rotor constantly rotates because of the wind force, so the magnetic field changes constantly, and that's how we can get a constant supply of AC current from the conductors. Now, in a three-phase generator, instead of using one single conductor coil, three different conductor coils are used, and those coils are placed symmetrically 120-degree phase shifted positions. Since the common rotor rotates with an equal speed, so the frequency for all three phases will be similar. However, the coils are physically shifted 120 degrees from each other, so there will be a phase shift in time displacement, which will be 2 pi over 3, or 120 degree. It is necessary for all three induced EMFs to be even, with equal phase displacement between them. This represents the symmetrical three-phase system. A three-phase generator is only symmetrical if and only if the load at each phase has a similar impedance value and those impedance has equal phase angle. The voltage and current at each phase has to be equal, and the phase displacement between the conductors has to be 120 degree. A great advantage of using a three-phase generator is that we can have 3 times the power using only 1.5 times the copper. That means we are getting more power with a lower cost. Another advantage would be with a symmetrical three-phase generator, we can have a constant power delivery with no vibration or torque variation. Also, reversing the direction of the electricity is very simple. All we need to do is just interchange any two phases. For a detailed demonstration of experimental apparatus and the procedure, please go through these tutorial videos. These videos are taken in UTEP Lockheed Martin Lab. This is how the wind turbine looks like. It has 3 blades. It has a rotor where there is a magnet inside of it, and it has three-phase electrical power generation capability. We can control the wind speed We can control the excitation voltage for the electromagnet inside the rotor, and we can control the load on each phase using this control panel. The setup has a built-in software that gives out all the data that we will need to analyze the performances. It gives out the wind speed, the frequency, the total power output, and the voltage and the current for each different phase. Using those data, wind speed velocity versus generated power graph can be plotted. And you'll see that as the velocity of the wind will go up, so will the generated power. Uh, we can change the phase load using the control panel. And over here, you can see the result for 30% and 60% phase load. Using those data, wind speed versus voltage or current can be plotted for all three phases. Using different phase loads, different graphs can be plotted. These graphs will give us a better understanding of the performance of the AC generator. The report should discuss all the phenomena that's mentioned in here: the wind speed versus power, the wind speed versus voltage for each different phase, the wind speed versus time, and the effect of phase loads on power generation. Thank you. If you have any question, reach out to me through the email on the screen.